I did make it to the movies. Man, we're missing a lot of students this morning. Made it to the movies this weekend. It was interesting. My wife wanted to go see the Downton Abbey finale, so we went and saw the Downton Abbey finale, and we saw it on Friday, which was opening day. But we bought tickets like on Tuesday. It's like, okay, but I get tickets early because there's probably gonna be a lot of people there. So we did, and it was already sold out except for the front row. So we had to sit in the front row buying tickets 3 days early. And then we got there, and we were the youngest people in the theater. So, yeah. Woo! All right, Truman. Yeah, we were the youngest people there. So there's Breland again. Hello, Breland. So yeah, I walked into the theater Friday, and I just saw a sea of gray. I was seeing everyone's hair from behind. It was just like a sea of gray there. It's like, wow, we're the youngest people in the theater. So it was packed. And then my wife messaged my sister to brag that she'd gone to the movie. My sister had gone as well. My sister's older than I am, and they said they were the youngest people in the theater where they were at too. So it's just a lot of senior citizens going to catch the Downton Abbey. So I asked my wife Dan. I said, "Well, you're satisfied? Was it a satisfying ending?" And she said, "Yes." So I said, "Okay, well, that's what I want to know. I'm just making sure it was a satisfying ending." And I have a new monitor because my monitor died 2 days ago. So it's like, well, Friday actually, and they replaced my monitor. So now my monitor is a different shape. The other one was about square, and this is one of the really wide ones that's shorter. So when I present things, it may be different on your screen than it was last week, just because. So, all right. Well, with 10 of us in here, I think we got to get started. It is like we've been in class like 5 minutes now. It's 7:20. So, okie dokie. Let me put this on the screen. Let's take a look at what we got going on this week. Algebra 2. Let's click on our grade screen where we should start all of our weeks. And we see that you should have 4 grades when you go to the grade screen now, because last week was September 14th, solving systems of nonlinear equations. We also looked at lesson 1.04. We didn't have an assignment for it, but you should be done with everything up until, this week is the test. We have a practice test so we can make sure we're ready to take the test, and then we have the test, which is 2 parts. So we're going to look at that this morning. We'll look at the practice test first, and then we'll look at part 1 and part 2, because we're not going to learn anything new this week. We're done learning about systems of equations for now, and ready to move on to something else. So let's go back to our activity screen. Then we get down here, we have the system of equations review and practice test instructions. So let's go ahead and click on that. All right, this has the lesson summary for the 4 lessons we looked at. So if you want to look at, this should match up with your notes. If you're making notes, if you didn't make notes, it's not too late. It's all right here. Oh, your Chromebook needs an update. Yeah, go ahead and do that. Mine was asking for an update yesterday, and it shut me down. Right in the middle of a meet. I was presenting something on the screen, and suddenly everything went black, and my computer shut down. So you better listen to that if it's saying you have to have an update right now, because it'll force it. So here's the lesson summary for our first lesson we had, solving systems of equations algebraically, and it shows you these steps. Here's the steps for solving by elimination. By elimination, here's the 4 steps. And here's the steps for solving by using substitution. 3 steps. And both of them give you this little chart right here. It's like when both variables are eliminated. Remember, sometimes when we did elimination or substitution, the x and y would go away, and we'd end up with just numbers. So this has the little table that helps you interpret that. So if the variables are eliminated and you're left with a true equation, perhaps you're left with 0 equals 0, which is true, or maybe you got 4 equals 4 or something, you just end up with just numbers. And it's true. It's like, well, yes, 6 does equal 6. Then the answer is infinitely many solutions, because the 2 equations graph the same line. Remember that? We ended up with like 9 equals 9. We said, oh, well, that's because these are the same line. So the solution is every single point on both lines because they're the same line. So every single point, there's an infinite number of points on a line. So there was infinite solutions. The other case when the variables got eliminated was when we got a false equation. We ended up with like 0 equals 7. And we looked at it and said, wait a minute, 0 doesn't equal 7. 0 never equals 7. So if we get a solution like that, there's no solution to the systems of equation. And that's because if you graph them and look, they are parallel lines. They never touch each other. There's not a point that is on both lines. They're totally unique to each other. So that was a no solution situation. So it has that for elimination and repeats the exact same thing for substitution because it's still the same thing. If you're left with no variables, the x and y go away, and you just have 0 equals 0 or 7 equals 7 or whatever, infinitely many, or 2 equals 4, no solution. And then it has the steps for using elimination and substitution to solve systems of equations with 3 variables. Now, we haven't had to solve that, but we have to set it up. And the same thing on the test. We don't have to solve a 3 variable equation because that's a lot of work. We don't want to. I don't want to have to get into that. It's not really necessary. If we can solve 2 equations, as long as we know how to set up 3 equations, we could do it, but we're not going to. So this has the steps, which, if you know how to set up. And then it shows a little bit of the graphing, like where it shows 3 equations graphed right there. And so really it's where the graphical representation of the solution of system equations of the 3 variables is the point of intersection between the 3 planes. So if there's one point that's on all 3 lines, would be our solutions there. But we don't really graph 3 because generally with 3 equations, you have to have 3 variables. And we don't do an X, Y, Z graph. That's a 3-dimensional graph, which is very different. And this is trying to represent the Z plane right there. And it's a little harder to visualize. It's saying the answer is right there, I guess. But in the Z plane, it's a little different. So we don't graph. Desmos does not do a 3-dimensional graph. It does the XY 2-dimensional. And then we have the lesson summary for the second lesson, third lesson, fourth lesson. And if you wrote these down, that's your notes. That's great. You can use them in the test. If you didn't and you have a printer, you can print these and use these. Hey, put them in a little folder. Say, this is my notes for Algebra 2. Because these are the lesson summaries for all 4 lessons we've looked at. So you can use your notes on the test. You can use Desmos on the test. All right. Let's look. Oh, I can mark this complete. Okay. Well, not that it matters. There's no lesson and there's no assignment here. Then it says on page 2 to print the practice test. We don't have to print the practice test. They do have it there for download if you want to print it. But I have it right here in Buzz. This is the practice test they give us. So we have, I think it's 15 questions here. 15 questions. And let's look at the practice test. So this is one, we don't have to solve this either. It just says, what is the first step? If we were going to solve this system of equations, and this one I want to look at. Actually, I want to put this on paper because we didn't spend time talking about this particular situation. So we're going to work this one together, which we don't have to solve it. We just have to figure out what is the first step. -20. Okay, I've got that written down. Yeah, it says, what is the first step to solving this system if we were going to eliminate the y variable? So what's the first step if we're going to eliminate the y variable? So let me open this camera and we'll go through it. Now, our choices are this could only be solved by substitution. And we know that answer is wrong because you can always solve it by substitution, elimination, or graphing. Doesn't matter. This says rearrange the second equation to be y equals, so subtract 3y from both sides. Make the equations have -10 and 10y. Well, let's see. A good look at it. Turn on the light. Okay, it says, what's the first step if we're going to eliminate the y? Now remember, the way that we did by elimination is we would have like this one would be x plus 4y equals 7. And maybe we had another equation that was 3x minus 2y equals 3 something. And we said, well, if we want to eliminate the y, we need these to have the same coefficient but opposite signs. So we'd multiply this one by 2. And so this would become, the top equation did not change, but the bottom one, we multiplied everything times 2 on both sides. So this became 6x minus 4y equals 6. And then when we add these together, the y would be eliminated, right? Because we had a 4y and a negative 4y. So we just get 7x equals 13 in this case, which would give us a fraction answer, but that's okay. So the first step is to get these to be the same. Well, look at the one they gave us in the practice test. Can we get the y to be the same? We can, but it's going to take more than one step. We have to, this is -5 and this is 2, so those don't jive. We can't turn the 2 into a -5 or a +5. But we can multiply everything here by 2 and multiply everything here by 5. Thanks, Ricky. So if we multiply everything by 2 here and multiply everything by 5 here, what are the new equations? Well, let's go through it. Multiplying by 2, this is 8x minus 10y equals 8. I multiplied everything by, you have to multiply both sides or it's not the same equation anymore. It's a different graph. But we could graph this and it's the exact same equation, the exact same line on the graph. This one, we multiply everything by 5. 15x, 2 times 5 plus 10y. Negative 20 times 5 is negative 100. So now look, when we add these together, we have a negative 10y and a positive 10y. And that will eliminate. And we get 23x equals negative 92. That's what it's needing to happen. When we can't just multiply one, this one we could just multiply one equation and we make the same coefficient with different signs. Look, they both have a coefficient of 4, but one's a negative 4. Perfect. It can eliminate. This one, we can still do elimination, but you just have to multiply both equations by a number. Different numbers, right? I just multiplied by the number here. This is a 5, so I'll multiply this one by 5. This is a 2, I'll multiply this one by 2. That way I know they'll be the same because they're both 5 times 2. If it's 5, I'll multiply it by 2. If it's 2, I'll multiply it by 5. And I'll get matching coefficients with opposite signs. All right. So that gives us our first answer, which is make the equations have negative 10y and 10y. I multiply the first equation by 2 and the second equation by 5. I should say multiplying, but yeah. That is the first step. If you were to use the substitution method to solve the following system, write the new equation after the expression equivalent to y from the first equation is substituted into the second equation. Well, that's kind of wordy, but let's talk about what it means. I'm going to write this one down as well. After the expression equivalent to y from the first equation is substituted into the second equation. Okay, so that says they want to have the first equation substituted in here using the y, which means the first equation has to be rearranged to be y equals. We can only substitute for y if we know what y equals. So let's take this first equation and rearrange it. 8x minus y equals negative 9. So let me move the y to the other side. 8x equals y minus 9. See, now it's a positive y. And then I can move the 9 to the other side by adding it. 8x plus 9 equals y. Now we can substitute because we have y equals. So we can substitute into the other equation. So this is asking, what's the other equation after you substitute that into it? Well, take this, substitute it right there, and what is the new equation? I'm not going to solve it all the way to the finish, but I've given you everything but the very last step because you need to take this practice test. And here's the 4 choices. It should be one of these choices when you substitute that equation into the second one. Let's look at this. Connor went to New York for a vacation. He spent 3 nights at a hotel and rented a car for 4 days. Jillian stayed at the same hotel, but she spent 4 nights at the hotel and rented a car for 5 days. And they did this from the same company. So she stayed at the same hotel and rented a car from the same company. So that means the prices should be the same. If Connor paid $675 and Jillian paid $875, how much did one night at the hotel cost? Now let's talk about how to set this up, because that's the important part. Hotel, car. So we put that up. You said, okay, well, here's my 2 variables. One is a hotel, one's a car. So I can say X will be my hotel and Y will be my car. So the question asks, how much for one night at the hotel? So I'm solving for the X. I'm trying to get the X. I'm going to get an XY solution, right, with systems equations. But I only am looking for how much does the X equal. And when you look at that, it's like, okay, well, how do I set that up? Well, if Connor spent 3 nights at the hotel, Connor spent 3 nights at the hotel and rented a car for 4 days plus 4 days of a car. How much did he spend? He paid $675. He spent 3 days at a hotel, 4 days with a rented car, and he spent $675. Then you write the next equation for Jillian down here. How many days did she spend in the hotel? How many days did she rent a car? And how much did she spend? And that will give you your 2 equations. Then you just have to solve by elimination, substitution, or graphing, and then give the answer for one night at a hotel. So in other words, what does X equal? And you got 4 choices over here. All right, 3 teachers are taking their classes to the movies. They each have students, parents, and chaperones. Oh, so right away you have to think, okay, students, parents, chaperones. So just assign a variable to each. So students will be X, parents will be Y, chaperones will be Z. Mrs. Russell, here's the first teacher, brought 21 people. So if I'm writing an equation, that's all it tells me about Mrs. Russell, 21 people. So all I know is her students plus her parents plus her chaperones equaled 21 people. So there's your first equation, because you're setting up, write a system of equations to represent the people that all 3 teachers brought. So we don't have to solve, again, we don't have to solve this systems of 3 equations and 3 variables. We just have to set it up. And there's your first equation, which all of them have that one. X plus Y plus Z equals 21. X plus Y plus Z is 21. That's on all 4 choices. So it's setting up the equations for the other 2 teachers that's going to be different. So then you have Mr. Dodger has twice as many students, twice as many parents, and the same number of chaperones. And he brought 56 people. So set up the second equation. And I would do this on paper. I would do all this on paper and then compare it to the multiple choice and say, did I get one of those answers? If I didn't, what I miss? What I do wrong? What did I something I didn't pay attention to something? And then you got Ms. Kuhn has 3 times as many chaperones as Mrs. Russell, but the same number of students and parents as Mrs. Russell. So whatever Mrs. Russell's equation is for students and parents would be the same for Ms. Kuhn, but 3 times as many chaperones. And she brought 40 people instead of 21. So you just have to set that up properly. Here's one. Which graph represents this systems of equation? Here's a system of equation. Which graph is it? Now you can either rearrange this into y equals mx plus b and figure out what's the y-intercept and what's the slope. Or you can go to Desmos and say, oh, what does this graph look like? Because you can use Desmos on there, desmos.com. Go to the graphing calculator. Put this equation in. There's one of them. 4x plus 2y equals -2. There's one of them. So you just have to graph both of these equations and see which one of these looks like it. That's the easiest way to do it, since you can solve by graphing. If you have this equation, x plus 4 equals 3x plus 12, how can you set that up as a systems of equation? Because there's no y. But these have y's. This last one doesn't. So one of these 4 is the correct way to set this up. Again, setting it up is the biggest part of solving it a lot of times. If we can't set it up, then we have no chance. Oh, here's a graph, and you have to give the systems of equation that it represents. And they're all in y equals mx plus b. So you should be able to look at that, calculate the slope. Hint, I put a hint in there, determine the slopes of each line using rise over run. That's how we determine slopes on a graph. How much does it rise over each number that it runs? And then what's the y-intercept? So you should be able to determine which to. And if you're not sure and you said, I think you're looking at it, you think, I think it's this one. Well, go put that on a graph and see if that's what it actually looks like. Graph that. And you graph it and go, oh, no, wait, no, I think maybe it's this one after I graphed. Yeah, and I don't know which it was. I'm not solving it there, but write this system equation that matches this graph, but in standard form, which means you can start out in this form. Let's say I look at the graph and I determine, I say, oh, that graph looks like it has a slope of 4 and a y-intercept of -2. So I determined that this is the graph that I'm looking at. I see one of the lines, that goes through -2. Down here, -2, it has a slope of 4. And that's one of them. And then I got to do the other one. But they want it in standard form. So that just means the x and the y have to be on the same side. So the standard form would be -4x plus y equals 2. That's all it takes. When you have y equals mx plus b, to make it into standard form, you just have to have ax plus bx plus by, I'm sorry, equals c. You just have to have the x and y on the same side. So we just move the x over, and now it is in standard form. So you can determine that if you want to figure out the slopes and the y-intercepts, and then just rearrange it, you'll end up with one of these answers. Write the system equation that matches the following graph in standard form again. These are going to have the same slope. They're parallel, just different y-intercepts. So which of these pairs of equations is the equations for this graph? Two car rental companies have different rental plans. Sands car rental charges $50 a day and 10 cents a mile. Beach car rental charges $60 a day, and you don't have to pay for miles. So, how many days would the trip need to be to make the cost equal? If the trip was 300 miles, if you drove 300 miles and you try to figure out which car would be cheaper, how many days would it be where they're the same? So, if I'm going to be there less days, I'll go with the cheaper one. If I'm going to be more days, I need to go with the other one. But how many days would make it equal? So, you're just going to put 300 miles into the equation here. Add the 300 miles charge to the first one. It doesn't matter in the second one. There is no charge. So it'll just be $60 a day. And then you figure out how many days does it take until they're both equal. You can set up equations for that. You can set up table. It may be easier on a table. You can set up an equation and try to graph it, but I think you can think through that and figure that out. I like these. Charlie is analyzing two linear functions, f of x and g of x. For f of x, they gave us a graph. For g of x, they gave us a table. Will they intersect? And if so, what are the coordinates of their intersection? No, they'll not intersect. Yes, they'll intersect at this point. Yes, they'll intersect at this point. Yes, they'll intersect at this point. So if you want to visualize putting these points in the graph, -2, 4, that'll be right up here. And visualize with drawing a line between them. Where would it cross? Or if you want to figure out the y equals mx plus b and put this on Desmos, you could do that. You could figure out the slope. You can see the y-intercept. And then you could just plot those points. If I want to go to here and say, okay, so I got the point -2, 4. So I can put that point right on there. And you can put all the points and then visualize that straight line and figure out where does it intersect. Or does it not intersect? Maybe it's parallel. What are the x coordinates of the solution to this? So that'll have a solution, more than one solution probably, because that's a circle. That's a circle, and this is a straight line. So what are the two x coordinates? The x, just the x. Write the system of equations that matches this graph. And again, this first one is a circle, so it's an x squared plus y squared. Second one's just a straight line. Which of those is going to make this graph? And Denzel is analyzing a circle and a linear function. So we have the graph of the circle and the table that represents the linear function. Will they intersect? No. Yes, in quadrants 1 and 3. Yes, in quadrants 2 and 3. Yes, in quadrants 1 and 2. And I put a hint on there. Quadrant 1 is on the top right up here where the fx is. The quadrants are numbered counterclockwise, which means this is 1, this is 2, this is 3, this is 4. So if they will intercept, which two quadrants will they intercept in? Does it cut straight through there? 2 and 3, does that mean it cuts down through here? Where will it intersect? And then finally, our last question says, when planting his crops, he's planning on what to plant this year. He knows that his 7 acres can support peas and carrots. So he's got 7 acres, and he wants to make $7,000 this year. He can make $2,000 an acre of peas, the variable p, using p as the variable. He can make $1,000 an acre for carrots with the variable c. What equation would be one of the equations used in the systems of equations? So you can write the systems of equation. I got peas and carrots. I got 7 acres. I can make $7,000 an acre on the. I want to make $7,000 total. I can make 2,000 acre on the peas, 1,000 acre on the carrots, and this one of these equations would be in your systems of equation. You just have to figure out which one of these makes sense. That it could be one of the two. You don't have to have both of them. We just want to know which one, but not telling you whether it's the first or second. So you'll have to figure out which ones it is and go from there. All right. So that's our systems of equations. Oh, here, let me answer these real quick. Let's see. This is going to be, I'm going to say this one and this one and this one and this one. I'm just finishing my practice test because I'm ready to go to the test. I already threw an answer of that one. I'm going to throw an answer there, 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 there. Well, I answer that one? No. Okay. All right, let me turn to my test. How'd I do? Oh, man, I got a 26% up here. So that tells me, let's talk about this practice test. It's like, okay, the practice test. You're like, Mr. Brock, your grade just bombed. Actually, my grade didn't just bomb. I got a 27% on the practice test, but it's a practice test. It's a practice grade. It does not count in my. I still have 100% in the class. Woohoo! Even though I got a 27%, because the practice test does not count. The test is what counts. So the practice test is so you can take the practice test and you go, okay, I scored a 27%. I probably am not ready to take the test, right? Because I worked through there. I thought I had all the right answers. I thought everything was looking good. And I found out I don't know nearly as much as I thought I know. So now I need to go back and look at the practice test and see what I missed. Look at the work I did. Did I do it right? I thought it was right. I better go back and look at the lesson for that. Oh, let me look at that lesson because that's not what I thought it was. Oh, I missed a step. That's what I did. I should have done a step right here that I missed it. Figure out why you're missing these problems. So when I move on now and take the test, I won't have to worry about getting a 27 on the test. If I go back and look what I missed, I can take the practice test again. You can take the practice test 15 times if you want to. It'll let you take it over and over and over again because it's a practice grade and it's there for you to build confidence and understand, okay, now I took the practice test again. I got a 93. So I think I'm ready to take the test. I looked at the one I missed. I had a 93. I missed one. Oh, that had a negative. I didn't get the negative. I had it as a positive. Okay, I'm good to take the test. That's what the practice test is for, to help you know you are ready for the test. Okay, so let's go look. Oh, I'll show you something else because you may be look at the practice test. Let's show you how to look at the practice, see what you missed, because sometimes you struggle with that. And if you're new to Buzz, especially, let's look at the practice test that I just took. I got a 27%. I can retake it, see, but over here it says view grade details. So if I click on that, it'll say, okay, well, you made a 26.66. You completed it. It was due the 21st. You did it this day. But it's like, yeah, but I want to know what I missed. Well, look, there's a menu up here. This tells me how many times I've taken it. I've only taken it once. But if I click right here on questions, oh, here's all the questions. Oh, I got this first one right. I got the second one right. Oh, I missed the third one. Oh, that was the why. That was the car rental cost this much. I had it back. That's you're looking to figure out what it was. And you can go through each question and see what you missed, and it'll tell you what the correct answer was. And you're like, okay, that's what I'm. So I can go back and retake it now and then do better. And once I'm done and ready, if I'm not sure why it was wrong, look right underneath it. I have the practice test solutions. When I click on that, I can see what the correct answers were. Oh, here was the solution for number one, and this tells me how you get there. Here's number two. We had these to solve for using substitution. First, do this, and here's all the steps. Write the system equation based on the word problem. X is the cost of the hotel. Y is there. So here's the equations you start with. And then this uses elimination. We can solve it by elimination. All the way through. So this gives you all of the answers and tells you how to get there. So if you just go look at the answers and say, I'm going to get 100% practice test, and I can look at the answers and choose the right answer. Yay, yippee, who cares? It doesn't count toward your semester grade, and you just cheated yourself out of knowing whether or not you're ready to take the test. So this is here. This is for you to do after you write it down on paper and take the practice test. Like I said, work out the problems on paper. Then come look here on the ones you missed and say, what did I do different? What was wrong? And you can go through their steps and see what they did. Oh, okay, I see. You know, put both equations in standard form. Ax plus by equals c. So, but this has all the answers. So this is very, very good to help you check yourself on the practice test. Now let's actually look at the test because that's not what we really care about. This is what counts this week. Congratulations, you've completed the module. All right. We'll work on test. Give it 100% of your attention and effort. All right. Don't open the test and walk away from it. It might automatically submit it for you after a certain amount of time. And it only lets you take it once, so you don't want to close your browser and stuff and have it do that. But let's look at the two parts. Here is part one. Part one is multiple choice, and there are how many questions? 10 questions. 10 questions. All right. Mr. Brock went to a toy store that was still selling 2 Nintendo DS games and 4 Wii games for $240. Mr. Brewer bought 3 DS, 2 Wii, and spent 160. What was the price of one Nintendo game? So I bought 2 DS, 4 Wii for 240. Mr. Brewer bought 3 DS, 2 Wii, and spent 160. You can set up a systems equation. And what was the price of a DS game? So if you say that's X and the Wii is Y, you're looking for the answer for the X. Don't get confused. If you're using substitution, choose the new equation after you substitute X from the first equation into the second equation. So again, make that X equals, substitute it in the second equation, and which one of these situations would that end up with? Here's the one where you have to set up 3 equations with 3 variables. At a carnival, you got the roller coaster, the bumper cars, the Ferris wheel. Choose the graph that matches this system. Here's the system. Here's 4 choices. How can this be set up as a system of equations? Now notice there's fractions here. There's not fractions down here. It's because they set this up as 2 equations and then multiplied by the denominator. If I don't want to have negative 1/2 x minus 5, I multiply everything times 2 and the fraction goes away. If I don't want negative 1/3 x plus 6, I multiply everything times 3 and it goes away. But you have to separate this into 2 separate equations first, because right now it's 1 equation. You'd have to multiply it by 6, which is the common denominator between 2 and 3. Which equation does the graph solve? So which one of these is this showing the solution to? Choose the one that matches this graph. Which graph solves this equation? Negative x squared plus 1 equals x squared minus 4. It's 2 different parabolas set equal to each other. Here is a quadratic function and a linear function given as a graph and a table. Will they intersect? Put these points on here and look to see, does it cross the parabola? If it does it cross at positive x coordinates? That means it's in this area. Or does it only cross at negative, only in this area? Or does it do both? Does it cut straight across and cross in the positive and the negative? Or does it not intersect at all? And then we have a circle and a line. And if we put this line on that circle, will they intersect? 10 questions. 10 questions. And part 2 of the test, let's look at that, has 4 questions, but there's no multiple choice. It just has this blank area. And it says, solve this system of equations for x and show all your work. Now, you can give me the whole XY solution if you want. That's fine, as long as the x is correct. That's what I'm grading. And it doesn't tell you how to solve it. You can solve it by substitution, elimination, however, but it does say show all work. So if I'm typing these equations, y equals x squared plus 3 and y equals negative x plus 5, and I start doing my work and I do my next step and my next step and my next step, this can look a little bit junky altogether when you have a whole bunch of these equations, especially if it's a real long equation. If you are typing an equation in Buzz, whenever you are typing an equation in Buzz, this menu, if you go down to this end, oh, there is insert equation. Insert equation. Let me show what this looks like. I'm going to leave that one there. But if I go and I put that exact same equation in this box here and then save it, oh, wow, it's got an actual x squared. It's not an x little caret 2. And I can take this one, even though it's linear and not as hard to read, it still looks better as an equation form. Let me put it over by this one and then retype it over here. Y equals negative x plus 5. See, this spaces it out nicer when I do it as an equation as opposed to this, because that negative almost is disappeared. But it's real easy to see in the equation form over here. So, all right, oh, I can move it around. There you go. So anytime you're typing equations, use the insert equation button. Make it easy to read. This is so much easier to read over here than this. And especially if you're getting larger equations. Y equals 2x to the third minus 7x squared plus 3x minus 11. Boy, that looks like a mess. So that looks like a real mess right there. And the more equations you get on the screen, the worse it gets. But if I take that same thing, this is a lot easier to read. So, right, don't do this. Put the exact same thing in the insert equation right there. And so it looks like it should. So that's my little tip for that. Uh, a linear function that represents the number of hot dogs purchased at a football game is compared to a different linear function that represents the time left in the game. Describe the key features of the functions that are needed to determine if these lines intersect. Okay, here's the thing. You can't write an equation for either one of these situations. For how many hot dogs purchased a football game and how many a linear function that represents the time left in the game, because I didn't give you any data. I didn't talk about 3 hot dogs are sold every quarter or anything like that. I didn't tell you any of that. And it doesn't ask for a function. This asks, and let me emphasize, this asks for the key features. If I said, all right, I'm going to draw 2 lines on this graph, because it says these are both linear. It does say that. These are both linear functions. If I draw 2 lines in there, what's the important parts of those lines that determine whether it's going to intersect or not? Are they going to cross or they're not going to cross? Like, well, what do you think the key features might be? Would it be whether they're increasing or decreasing? Would it be their slopes? Would it be the y-intercepts? Probably multiple things. But that's all it's asking for. Tell me what are the key features you'd have to know if I said, okay, I graphed 2 lines, and I'm not going to let you see it, but do they intersect? So what could you ask me? Well, what are the slopes, Mr. Brock? Or where do they cross the x-axis, or where do they cross the y-axis? And you can ask a few questions and determine. Oh, I can tell you that they cross, or I can tell you that they don't cross just from what I've asked you. What would those key features be that you would need to know whether 2 linear functions cross? That's what this is asking. Key features. What are the important parts that you need to know? All right. And I also want to talk about part 2 being better than part 1 of this test. And you're like, whoa, Mr. Brock, part 1's multiple choice. True. 6 points each, multiple choice, 60 points. Second one's 40 points, 10 points each, 4 questions. But let's say you work multiple choice problems. You got it written down. You know what you're doing. You've got the systems equation. You're doing it by substitution or whatever. So you write your equations down, you change it to a y equals, you substitute it in the other one, you simplify it, you finally get down, you solve x equals. You go back and you put that x equals in, get the y. Here's my answer. It's 4, 2, 4 comma 2. It's the 0.42. That's the solution to the system's equation. And I look at that and I'm like, oh, that's good work. You know what you're doing, but oh, that should have been a negative right there. It's actually 4, negative 2. Multiple choice, you chose 4, 2. You didn't choose 4, negative 2. You get 0 points. That's the problem. 0 or 6. You get 100%, you get nothing. All because you missed that negative. Now, that same problem, now I've got it on part 2. And I say, show all your work. All right, which it does. So show all your work. And you do that exact same thing. You put the equations down, you solve it for y equals, you substitute that in there, you simplify it, you finally solve it for x. You give me the x, you look at the y, and you say it was 4, 2. And I look at it and say, oh, it was 4, negative 2. You missed a negative. But I'm going to give you 9 out of 10 points because you knew what you were doing. All the steps were right. This was good work. I can see you were solving it correctly. You just missed a negative. It's not 10 points or 0 points. You get 9 out of 10. That's still 90%. That's so much better than, well, it's multiple choice. You chose the wrong one, you get 0. That's why I really think part 2 is beneficial because you could miss every question. You could miss all 4 questions and still get a good grade because you're getting 8, 9 points, 7, 8, 9 points for each one instead of 0. So if you got 4 questions that you're getting 8 and 9 points for, you're still got to have a real solid grade. You're 30, 34 out of 40, 36 out of 40 by missing every single problem. So that's so much better than missing every problem on multiple choice and getting either 0 or 100% get them all right. Yep. All right, Dane. So show your work. When it says the more work, the better. The more you can show me that I know how to solve systems of equations, the better it is for your grade. Because when it's show your work, you want to cover yourself in case you miss a little negative or in case you mess something up somewhere along the way. But I can see, oh, you know what you're doing, but you missed this one step that it was a careless mistake. You knew it, but it was just a careless mistake. So you're going to get almost all the points because you were showing me that you were solving the systems equation. I'm like, beautiful. Let me show you some other things while we're talking about this because some of you are new to Buzz, so I need to make sure you understand how to do your best work here. Let's look at the other 2 problems first. Oh, yeah, I like to talk about this one because this confuses students at times if they don't realize this. Because I didn't put a hint on. I don't know why I don't have the hint on this one. I had a hint on there. Your boss hands you a memo with a summary of the monthly data. The number of imports is shown as f of x. That's right here. The number of exports is shown as g of x. It's right here. Using the data in the table below, representing both functions to explain to your boss the solution, you're supposed to explain to your boss what the solution to the systems of equation is. And what does that solution represent? Use complete sentences. So down here, you're saying the solution to the systems of equation. And now you're looking at it going, where's the systems of equations? Well, here's the key. F of x and g of x use the same month. This is the x, this is the y. This is the x, this is the y. This is really 2 separate tables. But since they share the same x, they just combined them to make one table out of it. But this is 2 separate tables. There's one table that has January, February, March, April, 2, 4, 6, 8. The other table has January, February, March, April, 3, 5, 6, 7. It's 2 separate tables. They just put it together because it's like, I don't want to repeat the months twice. So I'll just make one table. So it is a systems equation. You have 2 different systems. They just combine it as one table. So don't let that confuse you. Tell me what the solution would be. What is the solution to a systems equation? If you got 2 different solutions that have the same x's, where are they equal? Where are they the same? What's the solution? And then in this situation, what would that solution represent? Because we're talking about a business that imports and exports a bunch of stuff. And when you tell the solution to the systems equation, what is that? And then the last one uses graphing. You remember substitution, elimination, or graphing. What's the solution to this system of equations? And why? Explain your reasoning. If you go in here and say, oh, the solution is the 0.43. Okay. 43 is the solution. Okay. Why? Tell me why. because dot 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 dot. All right. So when you do that, and let me tell you, 4-3 is not the solution because it's over here and it's not on anything. It's that point right there. 4-3 is not the solution. Don't put that because Mr. Brock put that. I'm just doing an example that's wrong. But tell me, why is that the solution? And it doesn't have to be like this big paragraph. It's very simple. Oh, this is a solution because boom, this is what I see on the graph. Because it's graphed, right? So you can just tell me what you see on the graph and why it's the solution. This is what I see. Here's the solution. Because this is what I see. All right. Let's see. What else was I going to show you on this? Oh, here's what else I was going to show you. And it's like, okay, I did all this, Mr. Brock, but I did it on paper. Do I have to type all of that in here? No, you don't have to. You can insert a picture of your work on paper as long as you can read it. Now, some people take a picture and it's like half in the shade, and it's blurry, and it's like there's nothing I can read there. I can't give you a grade. I'll have to give you a 0 because I can't read any of your work. If you're gonna take a picture of it, make sure it's a good picture. Make sure you got the lights on, it's in focus, you got a good picture, I can see your work, and then you can just drop the image here, and I can grade that. That's not a problem. If you did it on paper, turn in what you did on paper. You don't have to retype it all right here because you might miss something when you retype it when you had it right on your paper. So you can do that. Or you can make a video, you can make a YouTube video. Oh yeah, you don't have to. You can insert a video right here, make your own video. Here's a video of me working the problem. Now I actually have had one student do that. I did have one student that made a video and worked the problem on video. And it's like, great, if that's what you want to do. So, all right, but use this insert equation. That's the main thing I want to emphasize on there. Use that insert equation. So, okay. Any questions about the test? We know we got the test. We're straight up. We got a practice test that helps us know that we're good to go, and then we have the test. So, all right, we have some time left in this class, so I'm going to let you have this time to start on the practice test. Give you some time before your next class that you can go ahead, and there's only 15 questions on the practice test. Usually our practice test will be a little longer than that. I'll give you, but that's all we needed for this one to kind of cover everything. So I will mute myself. You can work on the practice test, and then whenever you are done working, you can leave. But I want to give you some time to do that because I know that and the test can be a lot. So. All right, you guys got the rest of class. I'll be here if you have questions. So you can say, hey, Mr. Brock, I'm working number 4. I'm confused. I tried to do this. How do I do that? We can talk about it. So, there you go. You got the rest of the time.